this lecture, which is on topic Introduction to Quantum Mechanics. In this lecture, we have to study what is the origin of the quantum mechanics or what is the necessity of the quantum mechanics. Up to your 12th class, you have already studied what is meant by mechanics. So as you know, mechanics is the branch of physics which deals with a study of motion of objects. For this, we apply the laws of motion which was given by Newton. Later on, these laws are modified by other scientists, and that mechanic is called as the classical mechanics. So classical mechanics, in which we study the motion of objects which are directly visible or can be made visible by microscope. But if there are certain objects which are not visible by our eyes, or these are extremely small. Extremely small means what? If the size of the object is less than 10 raised to power minus 8 centimeter. In that case, we cannot apply the laws of classical mechanics. So we have to use another mechanics which was given by scientist Max Planck, and that is called as the quantum mechanics. So quantum mechanics is used to study the motion of the objects which are very small. Very small means having dimension of the order of 10 raised to power minus 8 centimeter or less than 8. Such objects are atoms or subatomic particles like electrons, protons, neutrons, etc. Another factor is size. One of factor is size and other factor is speed of the object. If speed of the object is very high, in that case also we cannot apply the classical mechanics. In this case, we have to use the theory of relativity which was introduced by scientist Albert Einstein, and that mechanic is called as the relativistic mechanics. Now, speed of the object is very high means what? Speed of the object should be comparable with the speed of the light. In that case only the theory of relativity will be applicable, and we have to use the relativistic mechanics. Now, what happens if the size of the object is very small, means it is a microscopic object or particle, and it travels with a speed which is comparable to the speed of light. In that case, we have to apply both the mechanics, quantum mechanics as well as the relativistic mechanics, and that mechanics is called as the relativistic quantum mechanics. So here, as per the size of the object, according to the size of the object, we have to use the quantum mechanics. But at the end of the 20th century, there are different experiments which were performed by different scientists, and theoretical result or explanation of these experiments cannot be given by the classical physics. So these are the limitations of the classical physics. So here we study certain limitations. First one is the Blackbody radiation spectrum. Blackbody radiation spectrum, which was studied by Lummer and Prinsheim. Experimental results were studied by Lummer and Prinsheim, and its theoretical explanation was given by scientists Wien and Rayleigh and Jeans. So there is a Wien's law to explain Blackbody radiation spectrum, but Wien's law can explain the Blackbody radiation spectrum only in a shorter wavelength region, not in a longer wavelength region. Later on, Another attempt was made by Rayleigh engines. They also used the classical theory, classical laws, and tried to explain the blackbody radiation spectrum. They can successfully explain the blackbody radiation spectrum in a longer wavelength region only, but not in a shorter wavelength region. Hence, both these laws, Wien's law and Rayleigh-Jeans law, which are based on classical physics, fails to explain the complete blackbody radiation spectrum. And scientist Max Planck then thought about a new theory, and by using his new theory, that is the quantum theory, he derived a law that is called as the Planck's radiation law, and by using that Planck radiation law, blackbody radiation spectrum can be successfully explained. And here this is the origin of a quantum mechanics. But there are also certain experimental results which cannot be explained by classical physics. Stability of atom. Rutherford explained the structure of atom. According to Rutherford, atom consists of central positively charged nucleus and electrons are revolving around the nucleus in a circular orbit. It is known to us. But again, the great physicist Maxwell, in his theory of electromagnetism, explained that every accelerated charged particle emits the electromagnetic radiation or electromagnetic waves. Here, electron is a charged particle and it performs a circular motion around the nucleus, so it has a centripetal acceleration. Means electron is a accelerated charged particle. So during its motion, it must emit the electromagnetic radiation. So electromagnetic radiation will be emitted. Hence, energy of the electron will go on decreasing. So energy of the electron decreases means radius of the orbit also decreases, and instead of following the circular path, that electron will follow a spiral path, and finally it will incident with the nucleus or collide with the nucleus. So atom will not be stable, and in this way stability of the atom cannot be explained by the classical physics. Later on, by using quantum mechanics, Niels Bohr explained the stability of the atom by using the idea of stationary orbits. Alright. Then spectrum of hydrogen atom. Hydrogen atom emits different spectral lines that we have already studied up to class 12, that is Lyman series, Balmer series, Paschen series and so on. So origin of this spectrum of a hydrogen atom cannot be explained by the classical mechanics or classical physics. Then Heinrich Hertz performed an experiment of photoelectric effect. According to him, when light incident on a metal, then metal will emit the electrons, and that is called as a photoelectric effect. This photoelectric effect is frequency dependent. Energy of the incident photons depends on a frequency, or kinetic energy of the electrons which are emitted from the metal surface depends on the frequency. But according to classical physics, that energy should depend on the intensity of the incident radiation, but practically it is frequency dependent. So its explanation cannot be given by the classical physics. Later on, again by using quantum physics, Albert Einstein explained the photoelectric effect, and for his explanation he was awarded with a Nobel Prize also. Later on, Compton effect. A.H. Compton discovered a Compton effect. Its theoretical explanation also cannot be given by a classical physics. So in this way, classical physics fails to explain these phenomena, and by using quantum mechanics, we can successfully explain all these phenomena. So this is the success of the quantum mechanics. But I want to mention one thing here, that it doesn't mean that classical mechanics completely fails or it is completely wrong. classical mechanics is valid. Till today also we can use the classical mechanics to explain the motion of objects in our day-to-day life. For example, motion of a car, motion of a ball, then motion of satellite, motion of earth around the sun. In all these cases, or to explain all these motions, we apply the classical mechanics and it is valid. But it has a limitations, and we have already seen the limitation, that is depending on the size. If size is small, then quantum mechanics, and if speed is very high, comparable with a speed of light, in that case we have to use the relativistic mechanics. So I think your ideas regarding the introduction of the quantum mechanics will be clear. Thank you very much.